Okay, now let's get to the lesson 2. Okay? And lesson 2, we started lesson 2 with SI units. Okay, so what's the meaning of SI units? We said that SI units are units that used by the scientists in order to make their communication more easier. I mean in order to make or in order to transfer information between each other or share information, they use the SI unit to make the scientist in any another country understand what they are saying in its scientific research. Okay, so if they use meter, so the country or the other country should use the meter in order to share their information with each other. Okay, so what the units that they agreed to use in the SI units, in terms of the length or any distance, length for example, they agreed to use meter. Okay, okay, and for mass they use kilogram, and don't forget, it may comes to you gram, kilogram, megagram, so you have to know that it's only kilogram. You can't measure the grams or measure by grams in the SI units. Why? I know that grams is right, you can measure any mass with gram, but the SI unit that they agreed to use between them in the SI system is the kilogram for the mass. And last one for the time. Okay, they agreed to use the second. Okay, second. And you have to know also that the abbreviation of second is only S, not SCK. S, okay? So, what's the meaning of the SI unit? It's called International System of Units. So why they have written as SI? Because its origin comes from French name, System des International Units, or System International Units. Okay, so because of that it's begin with S and then I. And then let's get to the scientific notation or the order of the magnitude. What I mean by that? Okay, I mean if I have this number, for example 1000, okay, so in the scientific notation it will equal 10 to the power, and then you have to count the number of zeros, 1, 2, 3, so it's 10 to the power 3. And we can also ask you about the order of magnitude, and here the order of magnitude is 3. Okay, so then if I have this number 0.001, we make the same. We also put 10 or 1 times 10 to the power, and then you count after the point 1, 2, 3, 1, 2, 3. So, and because it's a decimal, it means that it's lower than the 1, it's part from the 1. So because of that, we put it as 10 to the power negative 3. Okay, if it was decimal, so the power will be with the negative. Okay, so what if we have number like this one? مثلا 4, 6, or مثلا 4, 6, 7, 8, and you would like to make it in the scientific notation. Okay, if he didn't mention the place of the point, put the point after the first integer number. Put the point here. So the number will be just like this, 4.678. And because you moved the point from here to this position, so you moved the point 1, 2, 3. So it's gonna be 10 to the power 3. Okay, 10 to the power 3. But at the same time, you decrease the number or you increase it. by putting the point here, so you increased the number, صح? So if you increase the number, keep the power by the positive sign. Okay? And then the final answer will be like this: 4.678 times 10 to the power 3. So if I'm asking you about the power, if I'm asking you about the order of the magnitude, you will say its order of magnitude is 3. Okay? So what if we have a question like this: 0.4231. Okay? And you would like to make this point move to this direction. So the number will be, after putting the point like this, 4, 2, 3, 1. I move this from this column to this column. So I move it how many columns? 1, 2, 3, 4. Okay? So I put here times 10 to the power 4. Okay? Then you decrease the number or you increase it? You increased the number. Okay, the point was here, it was 0.4, and now it's 4,231. The number becomes so big. Okay, or the number becomes greater than the first one. So when you increase the number, you have to make the power by the negative power. So it's equal 4,231 times 10 to the power 4. Okay? Okay. Then, significant figure. How to know how many significant figure do we have? And what's the meaning of significant figure? Okay? The significant figure is very important in the measurement because it describes the precision. It describes the details of the measurement. Okay? So, for example, if I'm measuring the length of my pen, like this pen, and you get any ruler, okay, so you may measure it as 5 centimeter or 5 centimeter, okay. And also, if you're more accurate or if you're more precise, you can measure it as a 5.1. And if you're more accurate, you can measure it as a 5.1, 2, 3, 4, etc. Okay, so these numbers is showing how detailed your measurement. If your measurement is so detailed, so it will measure the centimeter and measure the millimeter, a micrometer. So to which extent, or to which details you have this measurement. Okay, so significant number. I'll say at the beginning, any zeros on the left are not significant, like this, 0.012. So these 2 zeros are not significant, and we here only have 2 significant figures. Okay? And also, if we have zeros from the other side, like this one, 12, 0, 0, we will say we also have only 2 significant figures, because zeros from the right also is not significant. Why it's not significant? Because we don't here mention the magnitude of the zero. We just measure how many thousand. We have 1,000, 2,000, 3,000, but we don't mention these zeros. Okay? So here we only have 2 significant figures. But keep that in your mind. If you put here, okay, 0.1200. So these zeros on the right, but came before them point. In this situation, we measure the zero as significant number. Okay, so we here have 4 significant numbers. And 1 0 is very easy, is when it comes in between two integer numbers like 101. So when the 0 comes between two non-zeros number or two integer numbers, so it counted as a significant figure. So here we have three significant figures. 1, 2, 3. Okay? So what if I give you another example like this? 1 times 10 to the power 4, or 5 times 10 to the power -3. How many significant figure you have in this situation? Okay, so you know that the origin of this number 1, and in front of this one 4 zeros, because it's 10 to the power 4, and it means 10 times 10 times 10 times 10. So the origin is 10,000. And we mentioned before that the zeros on the right like this, we don't count them as a significant figure. So we only have here one significant figure. 1. So you can do it without any explanation or without any conversion, that if you have 1 times or any number times 10 to the power, you can cancel all of this and take this as a significant figure. So here we have only one significant figure, and also here we have one significant figure. Okay? Okay. Let's get to the summation and subtraction of the significant figure. For example, if you have number like this one, 1.231 plus 1.2. Okay? In the summation and subtraction, we put the result, and then we cut this result into the lowest decimal. What I mean by that, the result here, 1 plus 1 is 2. 2 plus 2 is 4. Then 3, 1. Okay? And which one is the least decimal, or the one who has less decimals? This one. How many decimal it has? It has only one decimal. So because of that, the final result should have only one decimal. So to take only one decimal here, you have to cut this number like this. So you will take 2.4. But keep in your mind, before you cut the number like this, you have to look this number can round or can't round this. 3 round or not. Okay, let's summarize the rules of rounding. Okay, let's keep it as if it was 5 or more, like 6, 7, 8. So it round out. It makes round. But if it was less than 5, like 4, 2, 3, 1, so you can't round in this case. So I'll give you another example. Okay? So let's say you have 1.43 and 7 plus 1.23, 2 and 9. Okay, let's make our summation. So 1 plus 1, 2, 4 plus 2, 6.6, 3 plus 3, 6, 7 plus 2 equal 9, and 9 we don't have any column instead of our in front of the 9, so it's also 9. And which one has least number of decimal? This one have 1, 2, 3 decimal, and this one have 1, 2, 3, 4 decimal. So the answer should has only 3 decimal, okay, or should have only 3 decimal. So we have to cut the answer here after 3 decimal. 1, 2, 3. But keep in your mind, this number can round because it's 9 and 9 is bigger than the 5. Okay, so 9 will round the 9, this 9. Okay, so when this 9 round this one, it give them 1. 9 plus 1 is 10. So this one will be 0 and it gives the next column or next number 1. And this one will be 7. So the final answer will be 2.670. Like this. 2.670. Okay? And for the multiplication, it's a little bit near or similar to this one. But instead of saying we take the least number of decimal, we say we take the least number of significant figure. And what I mean by that, if we have 2.01 and here times we have 2. Okay? So make your multiplication at the beginning. 2 times 2 equal 4. Point. 2 times 0, 0. 2 times 1, 2. And which one has less significant figure? This one. Have only one significant figure. Okay? So the answer should also have one significant figure. But there are three significant figures. So we have to cut this number and to get only one significant figure like this one. Okay? So in multiplication or division, we take the least number of significant figure, okay, from the numbers that you multiply with each other, like the 2 and the 2.01. Which number has lower significant figure or least? This one. One significant figure, so the answer should has only one significant figure. Okay? And then accuracy and precision. And I told you before, accuracy is how the measurement is close to the correct answer. What I mean by that, okay, if we have this game, you know, the game of the darts, okay, like this. We know that if you get your dart in this point, which is 100, you will be very accurate. Get here, so it will be very accurate. So why I'm saying you will be very accurate? Because the correct answer here is to get it here in that position or in that place. Okay? But if you tried and get it here, I say you are not accurate. So here you are accurate, but here you are not accurate. Okay? So let's get to the precision. Precision is the measurement of how exact or the details of your answer. Like this answer, okay, if the answer gets here 100, 0.1, 2, 3. So you are so detailed, so you have precision here. And in this situation, we can say also the repetitive experiment or the repetitive target. When you get to repetitive target, so you will be have precision. Like if you get the dart many times here, okay, it's about 10 or 7, okay, it's exactly 8. So you have played 8 times, and each time get here in the, if it was this one is 50, so this one is 25. So you get in that 25 position 8 times. So that means that you have consistency. Each time you get it at the same place. So you have precision, but not accuracy. You have here precision, but not accuracy. Okay? But what if you get it like this? Many times at the right position, like this. So if you get it in your target many times, so that means that you are accurate, and at the same time you have precision. Here you have precision because it's consistent, or You get it in the same position many times, and accuracy because you get it at the right position, your real target, which is 100. Okay, so here you are accurate and precise. Okay. Okay, let's get back. If you only made your experiment and you get the result, okay, and the result was, for example, 10, and because you are human makes error, okay, so because of that you can reduce this error or decrease your error. How you can decrease your error? You can decrease your error by taking many measurements. After measuring, for example, this pen, you have to make another measurement and another measurement and another measurement. Okay, so for example, if the first measurement was 9.7, the second one was 9.9, 9.7, 10.2, 10, 9.9, 10.1 centimeter. Okay, so which measurement I should take as the right one? No, you can't take only one, but if you have many measurements, you can get the mean for them. What I mean by the mean, you take all of your measurements plus each other. I mean, 9.7 plus 9.9 plus 9.7, etc. over their number. يعني هنا 1, 2, 3 over 3. That's the mean. Or you can get the median. What I mean by the median? At the beginning, you have to arrangement. Take the ascendingly or descendingly arrangement. Like, let's arrange this number. So which one is the least? 9.7. Okay, so here we have 9.7. Then 9.8. Do we have 9.8? No. Next, 9.9. 9.9. Then 10.1. 10 at the beginning, and then 10.1, and then 10.2. Okay, and then because it's a median, it means the middle value. So where is the middle value here? This one with this one, this one with this one. So the middle value here is 10. Okay, and what about the mode? Mode is the most repetitive quantity or the most repetitive measurement. So I'm trying to find measurement that has repeated many times. So if you search here, you will find that 9.7 has repeated here and in this position also. 9.7 and 9.7. So the mode is 9.7. Okay, and also as I said, you are a human. You make an error. So you can get your error percentage. The error that you made, the percentage of this error. How you can get it? For example, you're measuring the gravity or the acceleration due to gravity, which is 9.81. Okay? And this is the real or the accepted value. Okay? And when you measure it, you get it as 9.7. And this one is your measurement. It's not the real, it's your measurement. Okay? So, to get the error percentage, you take at the beginning your real measurement. Okay? So it's 9.7 minus the accepted measurement, the value that many scientists or many people are accepted this measurement. So 9.7 minus 9.81 divided the accepted, divided by 9.81. But here you have to remember that because it's percentage, you have to make it times 100. And also sometime you will find this one was negative because this one is less than this one. So just remove the negative, because here we have modulus, and you know that the modulus remove the negative, or you can put the greater number before the smaller number. يعني you can put 9.81 before 9.7. Okay, so you can put the modulus, or whenever you get any minus, you can remove this minus or cancel this minus or cancel this negative value. Okay, and now we only have one part to finish this lesson, or to finish this section. Okay, and this part is very important, and I know that this part is included many times in your exam. What's the name of this? Okay, this part will be the SI prefixes, or the prefixes. What I mean by prefixes? I mean if you have very large value like this one, 1000, it's not very large, but we can make it larger like this, 1 million. Okay, so if you have 1 million gram, okay, instead of writing all of this number, you can only write only one letter. You can only write mega gram. Okay, and instead of writing the very small number like this, 0.001, for example, okay, so you can say, or you can write, if it was gram also, you can write only, instead of this, you can write milligram. Okay, but in order to know about the rules or the criteria that I remove this and put milli, or the criteria I remove this and put mega, you have to follow me at the next. Okay, we have here any unit, like meter, like gram, like second, okay, at the middle, like this. And if this, or if the number was very large, you can reduce the number with these prefixes, with large prefixes. The first one, when the number is 10, okay, you can remove this 10 and put the word deca, okay, or 10 to the power 1. Then, if the number was 10 to the power 3, means 1000, يعني, you can remove this one and put kilo or K. And if the number was 10 to the power 6, you can remove this one and put mega, or only M, or only K, or only D. Okay? Next one. If the number was 10 to the power 9, okay, you can remove 10 to the power 9 and put giga. Okay? Next one. If it was 10 to the power 12, you can remove this one and put beta. And if it was 10 to the power 15, you can put exa. Okay? So what if you have very small number like a decimal, like 0.01, 0.001? How can we represent these very small numbers? Okay, you can represent them like this. If this number was very small, like 0.1, or this one consists of 10 of these, so you can remove this 10 and put DC meter, okay? Means also 10. Means the meter consists of 10 DC meter. DC. Okay? And then if it was 10 to the power 3, so it's milli. 10 to the power 6, so it's micro. If it was 10 to the power 9, so it's called nano. Then 10 to the power 12 pico, and 10 to the power 15 is called femto. Okay? Mister, you have made a great mistakes. You didn't put the negative here. صح? Okay, I mean that. I didn't put the negative because you have to know from where and to where you like to go. Because if you get from small to larger one, you will keep the negative value. And if you get from larger one to smaller one, you will what? You will remove, or you will remove the negative value. What I mean by that, for example, I get from here 5 gigabytes. 5 gigabytes. Okay? How I can convert it into the byte, only byte. Okay? Okay, you just look like right here. So giga is 10 to the power 9. So we'll take this 5. You will say 5 times 10 to the power 9. And then look, you get from the larger to the smaller, or from the smaller to the larger? No, giga is larger. So you will keep it positive as it is. 5 times 10 to the power 9. Okay? So what if it was like this? And instead of from gigabyte to the byte, I'll put, for example, millibytes. Okay? Take this way, or take this procedure in order, inshallah, to make the right conversion. Just see how many prefixes do you have? 1, 2. Okay, so that means it has 2 steps. The first one to remove the giga, and second one to put the milli. Okay, so giga equal 10 to the power 9. So I'll put 5 times 10 to the power 9. Okay, now I removed the giga. Then from the byte to the mega, from the byte to the mega, from the unit to the milli here. So we have times 10 to the power 3. Milli 10 to the power 3. So why you didn't put the negative? Because I came from the larger to the smaller. Okay? Then the answer will be 5 and then times 10. Here we have 10 to the power 9, and here we have 10 to the power 3. And because the base is equal, so we take only one base and make a summation for the power. 9 plus 3 equal 12. Okay? So the answer will be 5 times 10 to the power 12. Okay? Let's take another one. From 10 to the power 15 picometer, okay, to kilometer. Okay, you have to ask yourself at the beginning, how many steps? To know how many steps, look how many prefixes do you have. You have 1, 2. Okay, so we have 2 steps. The first one to remove the beta, pico. Okay, so you get from the pico to the less one, to the meter, from the pico to the meter. Okay, to get from the pico to the meter, you will multiply times 10 to the power 12. So I'll say 10 to the power 15, this one, times 10 to the power 12. Okay, but keep in your consideration that you came from smaller one to larger one. And when you came from smaller to larger, you have to put the negative. So here it's negative 12. Okay, so now we just converted from pico to meter, from picometer to only meter. How to convert it by the next step to kilometer? From meter to kilometer. Okay, meter smaller to kilometer larger. So you will also multiply times 10 to the power 3 times 10 to the power 3. Okay, and you get from the smaller to the larger, so it should be negative 3. So the answer at the end will be equal we have the same base, 10, 10, 10. So I only take only one base, 10. And make a summation for all of these power. 15 plus negative 12 plus negative 3. Negative 12 plus negative 3, negative 15, right? Negative 15 plus positive 15 equal 0. And 10 to the power 0 is equal 1. Only 1. So 1 what? 1 kilometer. So that means 10 to the power 15 picometer equal to 1 kilometer. Okay? Simple and right? Okay. Also, some students misunderstand the word or the question when it came like this. When he asks you like, how many seconds in 5 megaseconds? How many seconds in mega in مثلا خليها 5 megasecond. They think that they have to convert from second to megasecond. But the opposite is right. No, you convert from megasecond to second in order to know how many seconds in the megaseconds. So we will take this like this, 5 megasecond. You like to convert it into only seconds. Okay? And I said before, write the second as only S letter بس. خلاص? How many prefix do you have? You only have one prefix. How many steps? So it's only one step. Okay? So I take the 5 times. It's mega. Mega is equal 10 to the power 6. So it's times 10 to the power 6 second. Thank you. Okay? Okay. So right now we can say that we end this lesson, and we will take inshallah more problems and more practice in the revision sheet inshallah.